Okay, so welcome Michelle and Erez and Michael and Lizzie, and welcome Kamal. So thanks for coming. What we're gonna jump into is the quiz. So let me share my desktop so we can check out the quiz. Okay, so here's the quiz. Okay, suppose a study was done to look at the relationship between the number of hours, A, people exercise per week when they're in their 20s, and the age, B, at which they die. The results of the study are shown below, okay? And I want to remind you, suppose means I just made up the numbers, but a study like this could be done. Obviously, it would take a lot of years to finish it, but it could be done. And here's a bunch of data. And then there's a lot of things to do. First thing is to write down the null and alternative hypotheses. So notice here, even though, of course, you may be thinking of it because we're in chapter 12 this week, or we just finished chapter 12, but this is regression analysis. And it's regression analysis because we're looking at two quantitative variables. We're not trying to find out if there's a difference between them. We're not trying to see, hours of exercise, if that's the same as the year you die. That doesn't make any sense. We're trying to say is hours of exercise a predictor, a linear predictor of age of death? Any questions on that idea? Any questions? Okay, and I just realized, there we go. Okay, so we need to write down the null and alternative hypotheses. And as I mentioned on Thursday, the null alternative hypotheses for regression analysis are in our class will always be exactly the same. So I'm gonna make it pretty and use an equation editor. So we have H naught. Oh, that's right, you can't do a colon, so I have to insert. It's kind of a pain. Then I do the colon, and then I do a new equation. Okay, what is H naught when you're doing regression analysis always? That's something you're all supposed to know because it's always exactly the same, never changes. What's H naught? Yeah, rho equals 0. Okay, so rho equals 0. And again, you don't have to use the equation editor like I am. You can write RHO, that's fine. But I like to make it look pretty, but you don't have to. So there's the rho, and then equals 0. Any questions on H naught? Okay, now let's do HA, and I think what I'm gonna do is I'm gonna copy and paste.
Real fast. Is that acceptable? Just like that? No written out wording, just like that is acceptable.
Yeah, in fact, that's required.
But I mean, you don't have, like, obviously that's it, but you don't have to, in addition, since this chapter was more words than numbers, you don't have to also write it out.
No, because part B, you're going to basically write it out.
Okay.
Do you see? Sorry, not part B, part C.
I know.
Part C. So part C, we're going to write it out. Part B is just 2 numbers. Part C, we're going to be writing it out in words. Okay. Does that make sense?
Yeah.
So part A is to write the symbols. What is the null and alternative hypotheses? Remember, chapter 11 is words, and all the rest of them so far, including chapter 12, are symbols only. Okay. Chapter 13 is going to be a mix, as we'll see in a bit. All right, so let's go fix this up. And if we want to find out if there's a correlation, what is the inequality for the H1, for the alternative hypothesis? So its rho is?
Different than.
Yeah, different or not equal to. Any questions on part A? Okay, and again, if you write, NOT with and then equal sign, that's fine too. But it looks prettier if I use the equation editor. Okay, now write down the test statistic and p-value. That's going to take a little bit of work, and work meaning just kind of busy work. That's where I need to go to my calculator. And which number should I use?
23 regression analysis.
Definitely. Definitely. So regression analysis is the test. It's the test for chapter 12. It's the only one we have. Okay, and then if you remember the way it works, we pop in the points one at a time. So I wrote down 477. Plot it. And then 053. And then 904. And then we had 261. And then we had 1498. And then 786. And then 469. $12.91. $6.71. Any questions on entering the data? Okay, once we have the data entered, then we just go and we look, and we're looking for the test statistic and p-value, and that is on the bottom here. The test statistic is t equals about 5.13. And the p-value was equal to 0.00135. And as I mentioned before, unlike the homework, number of decimals you carry it to, I don't really care very much. I'll make sure that small rounding issues aren't going to make any difference in whether you reject or fail to reject. Okay, any questions so far? Okay, now part C, that should answer your question. That's where we're going to write words. And that is state the conclusion of the hypothesis test in the context of the study. So for any hypothesis test, first words, you should all know the first words. What's the first words for every hypothesis test? Very important for the final, by the way. Yeah, there is statistically. And now the p-value is 0.00135. So what's the next word?
Significant.
Yeah, significant, because the p-value is less than any alpha you'd use. So it's statistically significant. Evidence to conclude that, and now what you do is you look at this rho not equal to 0, and in words, what that says is that there is a correlation between, and now remember what we were looking at was hours exercise when they're in the 20s and age of death. So between the number of hours People? Exercise? In their 20s? And the age when they die. Any questions on that? Any questions? Okay, write down the equation of the regression line. Again, that is given on the calculator. So all you have to do, copy and paste. Any questions on that? If you want to write y hat, you can, but you don't have to. So maybe I will. That just reminds you it's a prediction, not an actual. Okay, now interpret the slope of the regression line. Could we have used A and B? So A and B, the letters A and B are placeholders, right? Yeah, so the letters A and B are placeholders. As soon as you have data and you find the equation, there's no more A and B. Does that make some sense? Yeah, so in this case, if you just wrote y hat equals a plus bx, that's not the equation of the regression line. That's a general equation of all regression lines, but it's not the equation of this regression line. But that's not what you mean. I'm not sure what you mean then. Maybe part A and B? I don't think so. I mean, sub A and B for X and Y. Nobody does that. It's always X and Y. Sometimes you'll see Y hat. But A and B are never looked at as variables. That's a math thing. That X and Y, and you learned that at one point in your life, that X and Y are the letters you use for variables. A and B are placeholders for numbers. Does that make sense? That's how the question provided it at the top. Oh, capital A and capital B. That would be okay, but not lowercase a and lowercase b. Yeah, definitely. You could do that, but you have to make a capital then because it specifically has capitals. And little a and little b means something different. But better at X and Y. Yeah, if you use P instead of rho, it's not as good. Better is RHO if you don't want to use an equation editor. I don't think I'd take off points if you wrote P, but the problem with P is used for so many other things, in particular for proportions. So that's why you probably don't want to use the letter P. So RHO, or if you want to do equation editor, you can. But I probably wouldn't take off points, but it might be confusing for you also because it's not a proportion, it's a correlation. And that's very important because when we state the conclusion, we have to have that word correlation. And if you write proportion, I'm going to take lots of points off. So instead, we can say is there is. So again, this hypothesis, oh, sorry, I did that. So that's why in here in the conclusion, we specifically use the word correlation. And it can be confusing if you use the letter P, because that stands for proportion hypothesis test. Okay, interpret the slope. So let's interpret the slope. First thing, the slope, which is, I didn't ask you to do this, but for teaching purposes, I like to write that down. What is the slope? Maybe to 1 decimal place is good enough. What's the slope? 3.3. So that's the first thing, is the slope is 3.3. You have to know how to recognize it. And I like to write that as 3.3 over 1. That reminds me that the slope is a fraction, as in rise over run. The rise is the 3.3, and that is the dependent variable. The dependent variable is death age of death. Whereas the run is 1, and that's the independent variable, and the independent variable is exercise hours in the 20s. So now let's put things together, is that for every hour, people in their 20s exercise, and maybe even for every additional hour. We predict that on average, they will live 3.3 years longer. Any questions? Any questions on interpreting the slope? Okay, now let's look at F. F is interpret the y-intercept. So first thing, what is the y-intercept? What number is it? Maybe to the nearest whole number. Ah, right. So the key is you don't want to just have will, but if you have predict and you have average, then it's okay. So you got to have predict and average, otherwise you don't. But if you just write for every additional hour people in their 20s exercise, they will live 3.3 years longer. That's bad. Does that make sense? So when I meant don't use will, as in don't use will by itself, because then it means cause and event. Yeah, tends to is fine too. So they tend to is even better. So maybe I'll even change that to tend to. So then it has all the language, tend to, average, predict, all the regression analysis language. Okay, so what is the y-intercept? And both coordinates is always good to have for y-intercept. What's the x-coordinate of the y-intercept? Here's a hint, always. That's very easy, that's a hint. It's always 0 by definition. What's the y-coordinate of this y-intercept? Rounded to the nearest whole number. Yeah, 57. Okay, so now let's analyze it. Is 0 a possibility? Yeah. The funny thing is, not so much in Tahoe, but I'll tell you, if you go to Alabama, there are a lot of people that don't exercise at all. Okay. Tahoe, just about all of us exercise in Tahoe, but not true in other places. That's for sure. Just kind of sad. Okay, and they've done lots of studies on this. Okay, so 0 means don't exercise. And notice if you look at the data, we even had a 0. So it's definitely reasonable. Do you see that? You don't have to have a 0. If there was a 1, that'd be good enough too. But you should have something somewhere around 0. Okay, and then is 57 a possible number, a reasonable number? What do you think? Could 57 happen? Yeah. I mean, it's sad if it happens. You don't want someone dying at 57, but they could die. People die at 57 years old. Yeah, it definitely could happen. So this one definitely is reasonable. And now let's interpret it. And what we can say is the best prediction for the age of death for a person who doesn't exercise at all. That's what 0 means. When they're in their 20s. is to die at age 57. Any questions at all? Any questions at all on interpreting here? Okay, now use a regression line to predict how long someone will live if they exercise 11 hours per week when they're in their 20s. So it's supposed to be pretty easy. The hint is, here's our regression line. So let me copy and paste it because we're going to need it. So what do we do? The hint is it's easy. So if you, yeah, sub, and what do we sub for X? Not 20. This got to be very careful. Yeah, 11. 11. Okay. 20s is just, you know, the day that those are the years that they're doing the testing or doing the interviewing or whatever before they start waiting for people to die. So 11 is what we want to substitute in. So I'm going to go times 11, and then Google is my friend. On the final, of course, you're going to have to use the calculator that's installed in Proctorio. And it gives you about 94. Okay. You want 94 in a month, but 94 because trying to say that you know to the month when someone's going to live, that when they're in their 20s. Good luck. Okay, so 94. So that means your best prediction for someone who exercises 11 hours a week when they're in their 20s is 94 years old. Okay, any questions on that? Okay, now interpret R squared in the context of the study. So this is kind of long. Do you remember kind of how this works? Kind of helps to kind of look at these numbers. You don't need the numbers, but that's the idea. How do we interpret R squared? And by the way, R squared, let's go find it. About 0.79, even to 3 decimal places, but however many you want to call it. So 0.79, so let's write that down. R squared is equal to 0.79, and now we want to interpret it. So how does that work? Who remembers? We talked about it last week in a big way. Yeah, there's a large variation. I'm just going to write age of death in general. But if you only look at people who all exercise the same hours per week in their 20s, then the variation age of death on average decreases by 79%. It doesn't mean age of death decreases, it's the variation of age of death. So it means it's much more predictable how long someone's going to live. By the way, this is it's an interesting question. It's an important one in the real world. Who uses this particular study? Who cares about this study?
Life insurance companies.
Exactly, life insurance companies. Now, they may not do, because they can only do what they're allowed to do, but they definitely look at who you are before they give a quote on how much you have to pay for life insurance. For example, we could do the same idea with, smoking cigarettes. And if you smoke cigarettes, you're gonna have to pay a lot more because you're probably gonna die younger. Okay. Similarly, if you exercise a lot, you're probably gonna die older, which means that there ought to be, I don't know if they're allowed to, but there ought to be a discount in life insurance costs if you exercise a lot. Okay, and by the way, I know I made up these numbers, but only kind of. I have done research, and exercising regularly makes a huge difference in health. Okay, it doesn't mean that those who exercise have no chance of dying young, but on average, they tend to live longer. There's definitely a positive correlation between exercise and age of death. So I like this one because it's very real. I did not do a study of a bunch of people and waiting around until they died after they were 20, because I'm not old enough for that. I'm old, but not that old, because you'd have to be at least 78, right? So this person died at 98 and they were in their 20s, and I'm not that old. But the point is that those studies are definitely done. Any questions at all? Any questions at all on this quiz? Okay, so again, this is a useful one. I try and bring in useful ones. And so I can tell you exercise is a good thing. Any questions about anything so far? Okay, so if there's no questions, I'll let you know what I did while you guys were taking your quiz. Okay, and in fact, it took a lot less time than I thought. I just went to our library. Okay, and when I say I went to it, I did not physically go to our library. I went to the library website, and I went to the search articles, and I just searched for what we're doing today, which is ANOVA. And then I figured I'd throw in COVID-19. And I was actually surprised. I thought it'd be very hard to find anything since COVID-19 is pretty darn new. And, published articles take a while to get published. It was easy. There were so many already. So I grabbed one, and I'm not going to get into all the details, but I am going to briefly talk about it. So by the way, I just went into our EBSCOhost, which is, you all have access to this in our LTCC library. So anytime you want to do research, real research, not just like reading, CNN or something, but actual research, you can go into our library's website and you can find articles. And that's what I did. And literally it took 5 seconds before I found one. Okay, this isn't Malaysia, but I figure it's good enough. People are people. So here is the article. And it is Public Knowledge, Attitudes, and Practices Towards COVID-19, a Cross-Sectional Study in Malaysia. Okay. And I'm not going to read the whole article because it goes on and on and on. But the idea is, again, if you look at the title, we want to look at attitudes and practices towards, etc. And what they did, it was kind of interesting. I didn't read the whole article because I didn't have time, because the article is kind of long. Is they did a survey. And first they wanted to find out who people were. And they did male, female. They did by ages, 18, 29, 30, 49, or above 50. They did regions. Okay. And by the way, don't ask me any details on Malaysia. I have never been to Malaysia. I know it's very far away, and that's about all I can tell you about it. But there must be a central, northern, southern, and eastern, and Sabah, Sarawak, don't ask me what that is, in Malaysia. Okay, and they have their results, how many they asked in all these places. And they did it by occupation, public sector, student, private sector, self-employed, not employed, retiree, or other. They did income category. This is interesting. This is not dollars. I don't know what it is. Malaysian money, probably. I don't know what R stands for, but that's just a guess. And, you know, how much people make. So what they did is they broke up their survey respondents into groups, and they wanted to see if there was a difference from one group to another. And what they did is they did a knowledge assessment about COVID-19. So they did a questionnaire, and they asked a bunch of questions, and then each person, based on their answer to the questions, was given a score on how good their knowledge was about COVID-19. Okay, and again, I'm not the one that did the study. I'm just reading it, but I did have 5 minutes to read it. And that's all I had, but so I got to look to see a little bit what they did. That's why I'm not reading all the details for y'all, but that's what they did. Here's a bunch of questions. They asked you, for example, let's see if you all know, the main clinical symptoms of COVID-19 are fever, fatigue, dry cough, and body aches. What do you guys think, yes or no?
Yes.
Yeah, that's a yes, okay. Unlike the common cold, stuffy nose, runny nose, and sneezing are less common in persons affected with COVID-19. That's a yes also. Actually, I know a lot about COVID-19 because one of my good friends is a nurse. And we talk about it and she knows. So I'm not gonna read all of these, but there's a lot. So for example, persons with COVID-19 cannot infect the virus to others if they do not have a fever. I hope you all know that one. Right? That's false because you can infect others if you have it but don't have a fever. So asymptomatic people can't give it to someone else. A little bit less likely, but it can happen. Okay, and on and on and on. So what they did is they asked, it's a bunch of yes, no questions, but what they did is basically you got a score. So what they did is they said, how many did you get right and how many did you get wrong? So it sounds like a yes, no question thing, but it's not because your final score is a number. Does that make sense? And that's important to note in this particular one. When you're doing statistics, it's always interesting to have to decide, is it yes, no, or is it quantitative? This feels like yes, no until you think about what they're doing, and that is how many correct answers did they get? Did each person get? And that's actually quantitative. And they did a score per person. And I don't know if they actually, I didn't read the details to whether they did how many yes, no's or what percentage they got right. But either way, that's just a multiple of 100. Okay, so it's actually quantitative. Yeah, so the answer is whatever proportion you have, in terms of, and that's a number. And again, what I did is by searching, I don't know if you can see, but I did a search for ANOVA so we can highlight it. So differences in knowledge scores among different demographic characteristics were assessed using t-tests and ANOVA. So let's take a look at that. So we want to say is that our knowledge scores different across groups. Does that make sense? So I want to go back again over here. And let's start with gender. Okay. And by the way, gender in Malaysia, I guess, don't look at me, is male and female, period. That's all they did in Malaysia. Can you do a t-test for gender?
I suppose.
Can you do this with it? Huh?
If you're using an exact breakdown, but if you're interpreting it the way it's interpreted now, I'm not so sure.
Okay, the answer is yes.
Now. Even though there's answers where it's a specific gender, I'm not sure, like questioning gender.
Well, we're doing male, female because that's what it says.
Oh, I thought that was a question about all. If male, female was to this, but I thought we were asking in general, could we have done it differently?
Yeah, so the idea is, could we do a t-test? And the answer is yes. And the reason why we can do a t-test is because we're looking, this would be a 2-sample independent samples t-test. Do you see that? So the difference between 2 population means when they're independent samples. Because it's the mean for men and the mean for women. Does that make sense? And we want to find out, is there a difference between the male and the female's knowledge score in terms of the population mean? And by the way, they got a p-value of 0.001. So does gender matter? What do you think? So is gender a factor in knowledge of COVID in Malaysia? It's something you should all know. Take a look, 0.0001, 0.001, that's the key. So when you have a p-value of 0.001, what's the conclusion? Yeah, reject. There is statistically significant evidence that there is a difference in COVID-19 knowledge between men and women. Is that clear? Okay, so this is a review. That's a review from chapter 10. But hopefully this isn't something that, you know, is like way over your heads. This is what we've already done. Okay, what about age group? Can you do a t-test for age group?
Yes.
One more guess.
Nope.
No. And there's a reason. How many age groups are there?
So many.
Yeah, in particular, how many?
3.
3. Okay, you can't do a t-test for 3 different groups. T-tests are for 1 group and 2 groups, right? You could do a t-test for a single population mean. You could do a t-test for the difference between 2 population means. We can't do a t-test for 3 means. Is that clear? If you can't do a t-test and you're talking about quantitative data, what we're going to be doing is ANOVA. So that's the topic of the day, is to talk about ANOVA. For age group, they're going to have to use ANOVA. And again, you're never going to really know what ANOVA is, except that it's what you do when you have more than 2 groups and you have quantitative data and you want to find out if they're all the same or if there are differences. That's what ANOVA is going to do. So is age a factor, is another way of saying it, in knowledge about COVID? How about region? Can you do a t-test or do you have to do ANOVA? Yeah, this one's also has to be ANOVA because there are 5 different regions. T-tests are only good for 1 and 2. And this is 5 regions and you can't do a t-test to compare 5 different groups. Okay, note, by the way, the p-value is small. So even though we've never actually done ANOVA before, you should all know what it means if the p-value is small. If the p-value is small, what do we say? This is supposed to be easy, not a trick question. So if you have a very small p-value, what's the conclusion? Reject. And there is statistically significant evidence to support the claim that region is a factor in knowledge about COVID-19. Is that clear? Okay, and then occupation. So if you look at occupation, again, there's what? A whole lot of occupations. 1, 2, 3, 4, 5, 6, 7 different occupations. Forget a t-test. Not going to happen. But ANOVA works. Okay, given the requirements, which we'll talk about in a little bit, ANOVA is going to work. And the researchers used ANOVA. That's what it said in the article. And again, they found out that occupation was a factor in knowledge about COVID-19. Similarly, income category. Can't use a t-test because you got 5 different income categories, and you're comparing the different income groups and how much they know about COVID-19. So again, this is going to be an ANOVA. Okay, and ANOVA is used again when you have multiple groups, and each group is each person is answering a quantitative question. Okay, and by the way, it doesn't have to be people. It could be breed of dogs also, and they may not be answering anything. They could be watching the dog eat or something, you know. So when I say people, that's just to make it easier to remember. But statistics is not always all about people. This particular one is about people, because how much people understand the whole COVID-19 and knowledge about it. Any questions about this article? And I want to remind you, literally, this took 5 seconds for me to find this article. That's how common ANOVA is. ANOVA is definitely in the top 3 for tests that researchers used. Okay, ANOVA is a biggie. Okay, and I got some bad news that you're not going to completely understand ANOVA by the end of this class. To truly understand it, you need to take more advanced statistics classes. But you'll get the idea of ANOVA in this class. Okay, there's a lot more to it. And you won't even know what you don't know. Just let you know that, because I don't have time to go over all the stuff. It would take weeks. And I'm not going to. But you can trust me, it's really important. And if you want to do it right, then you need to, study up more, take another class in statistics. Or if you're doing it like, say, a master's degree, you get your thesis advisor to help you. Okay, or me. Could always email me and I'll help you too. So just let you know that all this stuff is, is harder than it looks today. But you won't be tested on any of the hard stuff. Okay, or it'll feel hard to you, but you're not going to be tested on the stuff that we don't do. Any questions on this article? Okay, I want to mention one more thing why you're willing to trust me, that's fine too. I want to mention one more reason why I went to Lake Tahoe Community College's library's academic search. And that is ANOVA is high level. So ANOVA is a test that's only used by researchers. You're not going to see it in just general news articles. You're going to see it in research papers. But it's used a lot in research papers. Maybe more than half of all research papers that do statistics will use ANOVA. That's how common it is. So any questions? Okay. One more thing I didn't mention that is very subtle, and I'm sure my guess is nobody noticed. And that is here, you will see it says T/F. So as you should all know, is that T is used for t-tests. Is the test statistic for a t-test is a T. Any guess on what the test statistic is going to be for ANOVA? It's not a trick question. Yeah, capital F, by the way. Yeah, so there's another distribution that is used to do ANOVA, and that's called the F distribution. And the F distribution is very complicated mathematically. The good news is you don't have to worry about it because whether using, my program, I did the mathematics and it all works. Or if you use someone else's program, they did the mathematics and it all works. So you can trust the mathematicians, but you should know that the test statistic is labeled F for ANOVA. Okay, that's really all you need to know. You don't need to know any of the, the formulas and equations to get it. Just all you have to know is a letter for the test statistic for ANOVA. It's called the F statistic. Any questions on that? Not too bad? Okay, let's do an example. I'm going to make one up because the real ones, by the way, you need big samples to really work, to make it work. And big samples can be done. It's just a lot of typing, and it would take me a half an hour just to type in all the data. Because if you're asking, 4 different groups and you're asking each of them 40, you're asking 40 people in each group. Now we're talking about 160 data values, and I don't want to waste your time typing in 160 numbers. So we're going to do something that you should never do in the real world, and that is small sample sizes. And that's just so that we can get used to it. But I want to give you that big warning that you should never do a small sample size with ANOVA or really anything that you're doing statistics for. Let's do an example. Okay, a researcher wanted to find out if the season that a person is born in is a factor in the person's high school GPA. Okay, so that's the old, I do it the other way, but that's the old astrology. And the question is your astrological symbol have anything to do with your GPA? Okay, and we can take a look. Any questions so far? So what I can do is I'm gonna show you. I think actually it'll be easier this way. Instead of a table, I'm gonna do it. I'm gonna show you the results a little bit differently. So we're gonna have winter, and the GPA of the students they asked in winter were 2.8, comma 3.1, comma 2.7, comma 3.9, comma 4.2. Okay, don't want the spaces, comma 2.2. That was winter. And then spring, 3.4, comma 2.7, comma 2.7, comma 4.1. AP exams count, by the way. I mean, AP tests count as a 5. And comma 3.0. That's good. So winter, spring, summer. 1.8, comma 3.7, comma 2.9, comma 3.3, comma 2.5. And then finally fall. And the fall GPAs were 3.1, comma 3.9, comma 2.1, comma 3.7, comma 2.0, comma 2.8. Any questions at all on the question? Okay, and I will let you know, I totally made this up on the top of my head. Don't quote me and like say, hey, there was a study that was done that my professor showed you. I'm making this up, but you could do a study like this. It wouldn't be very hard, actually. 2 survey questions, right? When were you born? And what was your GPA in high school? And be very easy. You ask a bunch of people and they tell you. Notice, by the way, the sample sizes don't have to be the same. Not necessary. Okay. But I will tell you, if the sample sizes aren't all over 30, it probably is wrong. And that's why I mentioned that earlier about large sample sizes. So never do a study with this small sample size. Okay, but if I gave you over 30 for each of these, we'd be here all day like typing. So I didn't want to do that. Any questions on that? I just want to mention that you don't ever do small sample size stuff in real work. All right, so hopefully you know what is the first thing we should do? Very first thing. The very first thing we should do. We've been doing these for a long time. How do you start? Not seeing y'all answer, but hopefully you can answer. So how do you start a problem like this? We're at the end of the class, you should know at this point, or the final won't go too well for you. There's kind of 2 good answers, one best and one I'll take. It's better to guess wrong than to not guess at all, by the way. I'm giving you time because this is important. Is how does this process work? Are you all asleep? Or are you confused? Hopefully you could hear me. Maybe my volume's off. So how do you start? So what's the first thing we do? I don't see y'all jumping in, but hopefully you need to. Y'all afraid? All right, maybe I'll give up on you. I'm not sure, but I really want you to answer. Okay, well, if you don't know, the very first thing you do is decide what test to use. Okay, so what test are we going to use for this? And it's going to be, there's 2 ways of thinking of it. One is obvious and simple and easy and useless. And that is?
The answer is ANOVA because that's what we're studying this week.
Right, and that's the obvious, easy, simple, and useless.
Right.
Because next week, I'm going to ask you the same question, and it could be any of them. Okay, so it is going to be ANOVA, but let's not think of it as because that's what we're doing this week. Because again, on the final exam, that won't help you at all.
No, but you said the easiest, so I busted out the easiest.
That was the easiest way of doing it.
Yes, you gave
Okay.
us options and I
But
chose.
now let's talk about why it's ANOVA.
Let's do it.
Okay, so the first thing is look at the data. Look at the survey question that you're going to ask each of these people. You're going to ask them, what is your high school GPA? Or was your high school GPA? And then somebody might say it was a 3.8. It's a number. So the first thing is we have quantitative data. Okay. We also are finding out if something is true. So that tells us it's a hypothesis test and not a confidence interval. Confidence interval is to find out how much something is, not if something is true. And this is a hypothesis test. Then you say, well, now we know it's a hypothesis test, and we know that we're looking at quantitative data. Now we say, well, how many categories or groups or survey questions are there? And we see there are 4 survey questions. Not 4 survey questions, 4 groups. Winter group, spring group, summer group, and fall group. So ANOVA is the only test we have that handles quantitative data to compare many groups. So that's why it's going to be ANOVA. So you want to go through that reasoning, or I will tell you, problem number 1 on the exam will not go well for you at all. And neither will 2, 3, 4, 5, 6, 7, and 8. Just let you know that. We'll talk about that on Thursday. So you really got to be able to identify what test to use. Okay, so that's the first thing, is test using ANOVA. Okay, maybe I'll write number 1 because that's how you start. Number 2 is, what is the null hypothesis? What is the null hypothesis? And you all better know you call that H naught. And then this is going to be new for you. Now we have 4 different means. So we have the mean for the winter, the mean for the spring, the mean for the summer, and the mean for the fall. And unfortunately, spring and summer start with the same letter. I can't do much about that. I'm going to use, for those 2, I'll use SP and SU. So what I'm going to now write is mu sub W. Uh-oh. Try this again. So mu sub W equals mu sub SP for spring equals mu sub SU for summer equals mu sub F for fall. So the null hypothesis is that the mean for the winter, the population mean for the winter, is equal to the population for the spring, population mean for the spring equals the population mean for the summer, equals the population mean for the fall. Any questions at all on writing down the null hypothesis? Okay, I want to mention something. This is important. Notice that the null hypothesis, how many words do you see in the null hypothesis?
Five.
0. There's no words there. It's a bunch of symbols.
You trickster.
No, it wasn't a trick. There's no words.
I was counting each one of those H naught as a word.
No, that's a symbol.
SP. I made those words instead of symbols
Yeah.
like they represented words.
Right. But I specifically want to say that because now we're in the chapter where H naught doesn't have words. Chapter 11, H naught had words. Now let's do H1. And this is why things get a little bit confusing. So H1 is the following. So what is the opposite, right? So H naught is that the population mean for winter is the same as the population mean for spring, equals the population mean for the summer, equals the population mean for the fall. What is the complement of that? What's the complement of they're all the same? Because H1 is always the complement of H naught, right? Any thoughts? Okay, unlike the question that I gave you a long time for, which was how do you start any hypothesis test, and that is decide what test to use. This one's actually tricky. And the complement of they're all the same is not they're all different. Okay, so you got to get used to that. It could be that winter, spring, and summer are all the same, and fall's different. Okay, so maybe those fall people, they're the special ones, and everyone else is all the same. But that still means H naught's false. So you can't just say, you can't just take all the equals and turn them into not equals. That doesn't work. Because that would say they all have to be different from each other. They don't all have to be different. Okay, instead, and what I have learned from experience is that if I show you in symbols, nobody gets it. So I don't do symbols. I gave up on that after 2 years of teaching when I looked at the final exam and I had 0 people get it right. So I'm not doing the symbols because they're really complicated. Instead, what I'm going to do is in words. And the way you can write the complement of they're all the same is at least 2 of the population mean GPAs differ by season born. So there's at least 2 seasons that have different GPAs, whereas maybe the others are the same. 2 could be the same, 2 could be different, and then you could have 3 the same, 1 different. They could all be different, but as long as there's 2 of them, as long as there's a pair that differs from each other, then they're different. So for ANOVA, you'll notice that H naught is all symbols and H1 is all words. So get that straight and get it down and do it right. Okay. There is a way to do symbols, and my experience is it's too hard. So I don't do it. Any questions on H naught and H1? Okay, the next step is to say, well, how do we get the p-value and the test statistics? We saw in the article they gave an F and a P, but they did it. Now we have to do it. And the good news is I created a calculator for it. So I programmed a calculator. And what we got, and I bet you could guess, given that this is the very last day of the entire class when it comes to getting new material. Remember, Thursday is this review. Given that it's the very last day, which calculator do you think we're going to use? What number? Anyone paying attention? Yeah, the last one, 24. Okay. So what I tried to do is I tried to do these in order. So this is 24, and that's ANOVA. And the way I program this is you're going to have data 1, data 2, data 3, data 4. It goes up to 8 after that. Then you should use a more advanced calculator. I'll never test you with more than 8 because that's just busy work. But in the real world, sometimes it's more than 8. In that article we saw, I think 5 was the highest for their number in the data set. So this calculator would actually work for them. Interesting. Sometimes it does, sometimes it doesn't. If instead of asking what season you were born in, if I asked what is your astrological symbol, then this calculator wouldn't work because there aren't enough. I think there's 12, but I'm not sure. I think it's one per month, but I'm not even sure about that. I'm not into astrology, so I think it might be 12. I know it's more than 8. Okay, but the good news is, because the way I wrote this question, oops, that's over here, is I can just copy and paste because I have it, you're just separating by commas. So there's winter. Here's spring. And then we have summer. And then we have fall. Any questions on getting the data in? If it's in a table, you're gonna have to type it one number at a time with commas in between. So I purposely didn't make a table on this. Okay, then leave the rest of them blank. Then I cross my fingers that literally this is the first time in the history of the world this has ever been used in class. I don't think any other classes have gotten here yet. I'm not sure, but I don't think so. I hit calculate. Good, it worked. Okay, and we have our test statistic, which is F. So let's just write test statistic. Is F is equal to 0.37. Then we have our p-value. And that was, I think 2 decimals are good enough for being able to make conclusions here. And there's our test statistic, and there's our p-value. Any questions on that? Okay, even though we've never done ANOVA before, my guess is that at least the first part, maybe all of it, you're able to write down the conclusion at this point. So what's the conclusion? At least the beginning of it. Yeah, there is statistically insignificant evidence to conclude. I like to write whether or not. There's a lot of ways of writing it. Or not. And the good news is I already have it written down in words. So I can just copy and paste. Make the at not capitalized. Ah, shoot. There we go. At least 2 of the population mean GPAs differ by season born. Or another way of saying it is there is statistically insignificant evidence to conclude whether or not season born is a factor in GPA. Sometimes you'll see it that way, so I figured I should show you both ways. The first way is more mathematical, and you won't see it by, for example, psychology literature, because they don't like math that much. But the second way is probably more likely the way you'll see it in literature and psychology, or maybe nursing, you know, some of the things that some of you might be interested in. So that's why I want to show you the other way. Any questions at all? Any questions at all on how this ANOVA was done? Any questions? Okay, so now what we need to say is, if this was a true study, would you trust it? What do you think? So would you trust it if this was a real study and this was an article and they gave you everything I've written down? Would you trust the article? What's your thoughts? So would you trust this article if this were in an article, just like it is? Any ideas? Okay, so do you think this was a well done statistical analysis? Yeah, so it turns out the answer is absolutely not. Okay, and there's more than one reason, but one reason I expected you all to get, and that is the sample sizes are way too small. What I want to do now is talk about what do you need? What do you need to have in order to do ANOVA? So this is requirements to perform an ANOVA test. Let me make that bold. So number one, and your idea of it's not big enough sample was right, but your grammar wasn't right because there was more than one sample. So we have to make sure that all of the sampling distributions are approximately normal. So first thing in this example, none of them are approximately normal because their sample sizes are so small, and I would guess that GPA is not a normal distribution. I know it isn't actually. I've been teaching a long time. So GPA is not a normal distribution. There's all kinds of problems with this. So even if 3 of those had a normal distribution and the 4th didn't, that's still not okay. So the central limit theorem tells us if you have over 30, then you have a normal distribution for the sampling distribution. So you have to have over 30 in all of them, but I will let you know that I'm not going to be able to answer the question, is what do you mean by not big enough sample? Because that's advanced statistics. There are hypothesis tests, statistical tests to perform to determine whether or not you have something that is a normal distribution enough. And the main one uses a Kolmogorov test. We're not going to do this one. So remember, I told you there's a lot that we're not going to do in this for this ANOVA. So sorry if I have to tell you that take another class and maybe you'll learn about it. But that's all I can say. What does GPA look like? Oh, what does GPA look on a graph? So it's not bell-shaped. It's not bell-shaped. It's kind of the haves and have-nots, right? There's the screw-ups in high school, and then there's the good students. So it's kind of bimodal-ish. Doesn't, and that's just from what I've kind of done. Yeah, there aren't that many people that have a 2.0 GPA. Let's put it that way. There's a lot under 2, and there's a lot over 3. So that's why you don't have a normal distribution, where the mean is actually hardly represented. So that's what's going on for GPA. But again, you don't have to know that for this class. But you can study it, you can research it, and you'll find the same thing. Okay, and I know that not from being a professor. Do you know what I know that from? It's high school. You know why I know? If you know, because I was on the school board for 9 years, and I was in charge of all the high schools. So that's why. So we looked at those things, and of course, everyone looked to me for data analysis when there was data analysis to be looked at, because I was a statistician on the board. It's good to have a diverse board, by the way. If you're ever voting, you always want different types of people on your board so that you have specialties. It's always a good thing. Okay, so let's continue. Here's another one that you would probably never guess, and that is if the sample sizes differ greatly, then the standard deviations, the population standard deviations must all be almost the same. Okay, and you would never guess that. Again, there's mathematics behind it. I'm not going to get into it, and we're not going to get into even how to tell. I just want you to know that that's a requirement. So if you have one sample of 100 and the other sample of 300, they differ greatly. You got to make sure the standard deviations are the same. And guess what? There's the hypothesis test for standard deviations being the same. But we're not going to talk about it. Any questions on that? You should all know what a population standard deviation is, though. Okay, so then there's one that basically is true of every hypothesis test. For any hypothesis test, what is something that you always have to have as a requirement? No? Here's a hint. We talked about it in the first week of class. Okay, not sure. The sampling was performed without bias. Okay, if you have bias, you can't do any statistics in anything. Hopefully you're used to that by now, right? But that's always an assumption. Whether it's project 1 or project 2 or this ANOVA we're talking about, you can't have bias. Okay, if you have bias, then it's useless. Okay, any questions on that? Okay, another one. Yeah, so it doesn't have to be simple random. Remember that there's other ways of doing it. You could do stratified by all the strata that might give you bias, and that's okay. You could do cluster with a representation by clusters, so you get rid of the voluntary response bias. You could do a mix of cluster sampling and stratified sampling to get rid of both voluntary response and bias based on type of person. Does that make sense? And that counts, and that's good enough. Simple random, remember, is almost always impossible. And so if you always had to do simple random, then we wouldn't even have this class. It'd be a useless class, because for me to just tell you, oh, I'm showing you all the stuff, and you know what? It's impossible, and you can't do anything. That would be a total waste of time. Okay, so that's why in your project 1, I had to explore either cluster sampling or stratified sampling, because that's how most people do it. Okay, except in manufacturing, and then you're able to do systematic sampling. Simple random is rarely done because it's usually impossible. Any questions on that? Okay, another one, and that is that the sampling and questioning was done in the same manner for each group. Okay, that'd be a very easy thing to have on this particular one, because you're just going to ask the person 2 questions. But let me explain when this doesn't happen sometimes. I don't know if you remember one of my very first jobs in my life. And I think I told you guys, I think. I worked for Carroll Davis Market Research, and I was one of the people questioning. Yeah, I was 12 years old and questioning people. And what we did is, because it wasn't just one person doing the whole survey, okay? A 12-year-old or even a 30-year-old isn't going to be able to do a very large study by him or herself. So what happens is you have a team of researchers, and you want to make sure that everyone on the team is asking in the same manner. So what we did is we'd have a meeting before we started by the boss, manager, and the manager would tell us what we have to do and how to do it and how to react to different things, so that we're all on the same page. How is 12-year-old legal? I don't think it was. But the 12-year-old doesn't get in trouble. The boss does. I don't think the boss is even alive anymore. I'm pretty sure she's not, because I think she was 50 years older than me or something like that, or 40 years older. So at this point, it doesn't matter if it was legal or not. Okay. So things were different in the old days, just let you know. Things were different. Things were different 40 years ago. Okay, so anyhow, so let me give you an example where this could go, where this is a big issue. Let's suppose instead of wanting to find GPA by when you were born, what if you wanted to find GPA by state you live in? Okay, and let's suppose we want to make sure the questions were done face-to-face, not on phone. Okay. The first thing is there's no way you could do that one person doing it. Logistically, it would be a complete nightmare to have somebody go to all 50 states and ask a bunch of people. So what you do is you hire people in each state. And you got to make sure that the person in Minnesota is asking in the same manner as the person in Georgia, for example. And that's what this number 4 is. Any questions on that? So easy to do in this example we did, but there are a lot of examples where it's not easy to do, where you have to really work hard to make sure everyone is on the same page. Any questions on these requirements? Okay. The other thing is The sampling is independent. So you have to make sure that we have independent samples instead of dependent samples. So this isn't 5 questions to each person. These are 5 groups of people, each being asked a question. Do you see the difference? So you have to make sure you have independent sampling, and that's usually not a problem. You also can't have groupthink. So, you know, if you ask a question, everyone shouts out loud their answer, then people might change their mind because someone else said this, and I'm going to say it too because I don't want to feel different or something. So that's where you get independent issues. Any questions on these requirements? Okay, what I'm not going to do is explain or do anything about how you make all these work perfectly, because that would be more advanced work. So any questions on ANOVA? Any questions about how to perform an ANOVA test? Any questions? Okay, let's see who we got. We don't have too many. Just have a few, not enough for big groups or anything like that. But I do want you to try one. So here's what I want you to try. I'm going to have you do independently, but you can get help from each other or me or Anna. And that is come up with a research project that you might be interested in learning about that involves ANOVA, of course. I guess I should write down, because I haven't yet, analysis of variance. I think I should write A, capital N. So that's how they get the word ANOVA, is the A, the first 2 letters are the same from analysis, the O is from of, and the VA is from variance. Don't look at me, it's just what they did. Okay, so that's the first thing. The second is make up data that might come up from this study. We obviously don't have time to like fully explore data, so I'm okay if you just make it up. The third is perform the ANOVA test. Any questions on the task? Any questions? Okay. And again, I want all of you to do this. I know I'm not having all of you jump in and answer my questions, but I want all of you to do 1, 2, and 3 by yourself. Get pen, paper, write it out, and then when we're done, let's see if you can present. And I'm going to give you, so we still have a half an hour, little, and hopefully you could do this in 20 minutes. But Anna and I can help. And you can use the chat box for questions. You can use your microphone for questions. That both works. And I'll be happy to help you out for this. So again, it doesn't have to be real. You're making up data, which, by the way, you wouldn't do in the real world. You wouldn't make up data. In the real world, you'd then spend a week or a month or a year or years collecting data. So at this point, just make it up. So I'm going to let you work for some time. But I'm going to be checking in on you individually, and hopefully you're listening. Hopefully you're all paying attention. And Anna, you can check in too. Sound good? So I'm going to be quiet for a little bit so that you can work. I think I'm going to do the following. Just so you have it on the page, you can see both. There. A little bit higher. So hopefully you're all working. In fact, I'm going to mute myself, otherwise I bother you. Now you don't have to, that's why I showed you my example. Don't do a sample size of 1, please. So yeah, you don't have to over 30. That's way too much typing. And if it helps, there's the calculator in the chat box. because now people want to hear it. Okay, so again, ANOVA is used when you have multiple groups, typically more than 2, and you have a quantitative survey question. And everyone's answering a number. So if we look at the data, whether it would be this winter, spring, summer, and fall, they're all numbers. They're not yeses and nos. So you always think of the survey question. That's the most important thing. And what is a person going to say when they answer that survey question? So always imagine that. Okay. Before ANOVA, what was the hypothesis test we did? This one you should all know too, because that was, we're talking about less than 2 hours ago.
Oh, regression.
Or 2 hours ago. Yeah. So that's the regression analysis. And remember, that's always H naught, rho equals 0.
Yes.
And then for our class, it's going to be rho naught
one
equals 0.
different than 0.
And that's when you have 2 survey questions. Each survey question has a quantitative answer. And what you want to do is you want to say, based on one answer, can you get an indication of what the other answer is going to be? And that's what regression analysis is about. Okay. Then it gets a little harder because now we're talking, history. Before regression analysis, what was the one we did before that?
Oh, ancient history?
No, it's not that ancient, but
Oh, is that the kind of history?
yeah, we're talking more than a day.
Oh, so we have worked on so many things lately. We've worked on.
What happened just before regression?
We had goodness of fit, homogeneity. We had independent tests.
Yeah. So independence. Let me go slow. I want to go slow.
Oh.
So we had test for independence, test for independence, and test for independence is when you have 2 survey questions, and the answer to both of those are qualitative. And so you have 2 survey questions with qualitative answers, and you want to find out, is one a factor in the other? Is a relationship between the 2? Okay. Then before that, we had chi-squared for homogeneity. And for homogeneity, we have 2 groups. Each group is answering a qualitative survey question. And we want to find out if the distribution of answers for the first group is the same as the distribution of answers for the second group, or are they different? Okay. Then before that, we had good as a fit. That's when you have one group answering one qualitative survey question. And you want to find out if their answers are what you expected them to be. And that might be all the same in terms of uniformly given, or it might be the same as last year, or it might be the same as normal or something like that. Okay, so now we're going to get more historical. Before chi-squared, then what happened?
We're talking like 2 weeks ago now?
Yeah, talking weeks ago, yep.
It's the devil, Larry.
Okay, so then we had the test for 2 population means or proportions. So let me do proportions first. So if you have 2 different groups, okay, and the survey question are yes, no questions, and we want to find out if the group's answers are different from each other, then that is going to be a test for the difference between 2 population proportions. On the other hand, if you happen to have 2 groups and their answers are quantitative, number answers, and you want to find out if one group is different than the other group in terms of the population mean now, that'll be the difference between 2 population means. Okay, for independent data. Okay. Whereas if you have paired data, and the most common paired data is each person answering 2 questions that are both quantitative and comparable. So not weight and height, because you can't do 5'7" minus 150 pounds. You can't subtract this. So they have to be subtractable. Then that is going to be hypothesis test for the difference between 2 population means with dependent data, paired data. Any questions on that? Okay, that was chapter 10. Before that, what do we have? Got 2 more. Yeah, then we have the hypothesis test for 1. So now if you have 1 group and 1 survey question, if it is a yes/no survey question, then you do a hypothesis test for a single population proportion. Whereas if you have the 1 group with 1 survey question and it's a quantitative answer to the survey question, then it's a hypothesis test for a single population mean. Any questions on the hypothesis test? Okay, let's go back. Okay, if instead of asking if they are different, if you ask how different are they, then what is it?
Confidence intervals.
Yeah, then it's a confidence interval. So confidence intervals give you how different something is. Either 2 things from each other, or just what is something. It may not be different. But how much do people do that? Okay, or what is the proportion about? And then it's a confidence interval and not a hypothesis test. So you want to get down, are you looking at trying to just make a decision, or are you trying to do an estimate? And if you're trying to make a decision, it's a hypothesis test. If you're trying to give an estimate, it's a confidence interval. Any questions on kind of that summary? Since I had a little extra time, I figured I might as well do that. And I'm going to do it again, by the way, on Thursday, because if you can't get that down, this final will go very badly for you. That's the hardest part of the final. And it's not because I'm tricking you or anything. It's just, that's what this class is about. Okay, and then there's the early stuff, probability and stuff like that. We'll talk about that on Thursday. But I wanted to kind of go over the 2/3 of the class in 5 minutes.
And so can we have a fabulous study guide like you gave us the last time for exam 2 on Thursday?
Study guide, or do you mean template?
All of it.
Yeah. So I'm going to give you a template.
Right.
So I have the final exam, and I haven't posted it yet. I had to write it first, and literally I finished writing 10 minutes before this class.
Of course.
That'll happen soon.
Okay, great.
But I still have 9 days, so it's not like I'm fast.
Of course, your 9 days feels a little bit different on your end than the 9 days on my end.
It's still 9 days.
They're the same 9 days, but mine sort of feel like they're flying.
Yeah, it is 9 days, so.
Yes.
So I don't feel guilty that I did it 9 days before you're taking it.
Nope.
So anyhow, yeah, so I'll do that. There's also a practice final.
Great. Super great.
And that has a key.
Great.
The practice final is not on Canvas.
Oh.
So it's a different kind of practice final. That's just on the internet.
Oh, okay. So is it already there, or are you still making that?
I think it's already there. I haven't looked at it to make sure it fits everything, but which isn't exactly the same thing as a templated thing. That's more blanket stuff. I also have written a couple apps.
Of course you have.
And that will help you on problem 1 and 2.
Super great. Wait a minute. I usually get problem 1 on your exams, and I think the final is classified as an exam.
I shouldn't say problem 1 and 2. Sorry. I'm going by old style.
Larry,
I'm going by pre-coronavirus. So not problem 1 and 2.
really, really good at my name. And since
Yeah, you better get problem one. Sorry. Pre-coronavirus, that wasn't problem one.
I want that bonus still.
Yeah. Well, you better get that one right.
Yes, I hope. Although Anna was.
I really mean problems 2 through 19,
Oh, okay.
which used to be problem 1 and 2.
All to be variations of how do I spell my name.
No. No. Problem 1 is the name. 2 through 19 are harder.
Oh, I guess. I don't know. I wasn't quite sure if I could spell my name the other day, but Anna worked with me anyway.
Yeah, I'd like this, an app to teach us our name. And I haven't come up with that app yet. No, you'll see the apps I made. I'll go over them on Thursday. I think I'm going to stop the recording though, because now we're done.
Okay.
And just a minute.